How do you build custom JavaScript promise utility functions? Imagine turning complex asynchronous tasks into simple, reusable pieces of code. That's what building custom promise utility functions can do for you in JavaScript. Promises are like promises in real life, they representing a future result. They help manage code that takes time, like fetching data or loading images. To create your own promise utilities, start with understanding how promises work. They are objects that have a state: pending, fulfilled, or rejected. When you build a custom function, you want it to return a promise that can be resolved or rejected based on the task's outcome. First, create a function that returns a new promise. Inside this function, use the promise constructor. The constructor takes an executor function with two parameters, resolve and reject. These are functions you call when your task succeeds or fails. For example, if you want to load data from a server, perform the fetch inside the executor. When the fetch completes successfully, call resolve with the data. If it fails, call reject with the error. Next, add utility functions that work with promises. You can make functions like promiseResolve, promiseReject, promiseAll, promiseRace, promiseAny, and promiseAllSettled. PromiseResolve creates a promise that immediately resolves with a value. PromiseReject creates one that rejects with a reason. PromiseAll takes an array of promises and resolves when all of them do, or rejects if any fail. PromiseRace returns as soon as one promise settles, whether it resolves or rejects. promiseAny resolves as soon as any promise fulfills, or rejects if all reject. promiseAllSettled waits for all promises to settle and then returns an array of their results, whether fulfilled or rejected. You also want to add methods like then, catch, and finally to your promise objects. These methods allow chaining. Then registers callbacks for success or failure. Catch is a shortcut for handling errors. Finally runs code regardless of whether the promise resolves or rejects. When building these, make sure that calling then returns a new promise so you can chain multiple operations. This is how promises work smoothly together. Supporting promise chaining means managing the promise state carefully. When a promise resolves, the value should pass to the next then. If it rejects, the error should pass to catch. Your custom functions should handle this flow properly. Also, follow the promiseAll standard, which defines how promises should behave. This ensures your functions work well with other promise-based code and libraries. Let's say you want to create a utility that loads an image and returns a promise. You start by creating a new promise. Inside, you create an image object and set its source. Attach event listeners for load and error events. When the image loads successfully, call resolve with the image element. If it fails, call reject with the error event. This pattern can be used for any asynchronous API that uses callbacks, wrapping it into a promise. Building these custom promise utilities helps you understand how asynchronous JavaScript works under the hood. It also gives you the power to create tailored solutions for your projects. Whether you are managing multiple fetch requests or handling complex workflows, custom promise functions make your code cleaner and easier to follow. They are a key skill for mastering asynchronous JavaScript and becoming more confident in web development.